Good morning, ladies. For today's lesson, I'll be going through some multiple choice questions with you with regards to the factors that affect rate of reaction, right, which I covered in the previous lesson. Okay, so please look at question number 3. Okay, so for this question, you are told that you have 2 experiments carried out. Hydrochloric acid was added to aqueous solutions of sodium thiosulfate. And notice that you are given the volume and concentrations of both the aqueous reagents, and the concentrations and volumes are different, right? And the question is, how would the results compare in experiment 1 with those in experiment 2? So they are interested in knowing about the rates of formation of sulfur and the total mass of sulfur formed. So for this particular question, what you have to remember is the sulfur formed is a product. So they are interested in the yield. What is the total yield, which is affected by the amount or the number of moles of the limiting reagent. Alright, so if you want to know how much sulfur is formed, you have to go and do a calculation on the number of moles of limiting reagent. Okay? Now, in terms of rate, alright, there are 5 factors that we covered yesterday. Okay, but if you were to look at the reagents that are used, hydrochloric acid is an aqueous reagent, and sodium thiosulfate, you're told, is also aqueous. So most probably, the factor that will affect the rate of reaction here would be concentration. And if you look at the concentrations given, you can see that it's true. 1 mole per dm cube versus 4 mole per dm cube. Alright? So in this case, just based on the concentrations alone, you can see that experiment 2 should give you a faster rate because of the higher concentration of hydrochloric acid as well as sodium thiosulfate. Right? So A is wrong, B is wrong, C is wrong. As for the total mass of sulfur formed, like I mentioned, you have to quickly do a calculation of the number of moles of the limiting reagent. So for experiment 1, same volume and concentration of both reagents, so you just do this once, 400 over 1000 times 1, which will give you 0.4 moles of each reagent. Whereas in the second experiment, I'm using 100 cm cube and 4 mole per dm cube, which ends up giving me the same number of moles of reagent. So the mass of sulfur formed should be the same, and that's why the answer is E. Okay, so for this particular question, you are given again 2 experiments. We want to measure the rate of production of oxygen gas from aqueous hydrogen peroxide. So from a previous question, you should know that hydrogen peroxide will decompose to form water and oxygen gas. So it's this reaction that the question is referring to. Okay, so what else are you given? You are told that the solution used, hydrogen peroxide, has different volume and concentration. Okay, so you're supposed to pick the correct graph that shows the experimental results. Now for this particular question involving graphs, you have to remember to look at 2 parts. The first part would be the initial gradient of the graphs, right, which will tell us the initial rate. Okay, so this is affected by the 5 factors: concentration, temperature, etc. The second thing to look out for in the graph would be the total amount of product formed. So in this case, look at the total volume of oxygen formed. Alright, and this will be affected by the number of moles of limiting reagent. Okay, So if you were to go back to the table, which shows you the volume and concentration of hydrogen peroxide, okay, I need you to be able to see that the first experiment uses a higher concentration of hydrogen peroxide. So it will show a faster initial rate of reaction. Okay, so experiment 1 is faster, and when you look at the graph, it should show you a steeper initial gradient. Right, so in this case, I would cancel out B, C, and D. Because for these three options, it shows that experiment 2 has the steeper gradient. All right. Now, what about the yield? Okay, so similarly to the previous question, you have to calculate the number of moles of hydrogen peroxide. So in the first experiment, in the second experiment, okay, so you can see that experiment 2 uses fewer moles of the hydrogen peroxide. So they should give you a lower yield, right? Less oxygen formed. So option E is wrong because it shows that 1 and 2 give the same volume of oxygen. Right, so in this case, the correct answer is A. For question 12, you are told that 2 experiments carried out under the same conditions of temperature and pressure, so that we know that temperature is not going to be a factor that affects the rate of reaction. All right, and the reaction is between marble and dilute hydrochloric acid. So experiment 1, excess powdered marble was used, 20 cm³ of dilute hydrochloric acid. In experiment 2, excess marble chips, same volume of acid. Okay, so a few things that you need to be able to infer from the information given is, number 1, the acid is the limiting reagent because you are told that the marble is in excess. So, given the same volume of HCl when assuming also same concentration, all right, then in this case you can assume that you have the same number of moles of HCl. So it will end up giving you the same yield. All right, it should produce the same amount of CO2. So Z is definitely out of the picture. Okay. Number 2, powdered marble versus the marble chips. So this is testing you on the factor of surface area. Okay, so the powdered marble would have a bigger surface area, right? So it will give a faster initial rate of reaction, which means that you should show a steeper initial gradient, right? So if you were to look at the graph X and Y, X has the steeper initial gradient, so this must be the one with the powdered marble, and this is experiment 1. Right, so experiment 1 is X. Okay, Z is not one of the answers. So Y is experiment number 2. Okay, so the answer is A. Question 27 is asking you, in which reaction is pressure least likely to affect the rate? Alright, so if you recall what we did the previous lesson, when we change the pressure, we're usually changing the pressure of a gaseous reagent. Alright, so the factor of pressure is applicable only to reagents that are in the gaseous state. So least likely to affect will not affect. All right, so in this case, you can see option A has a gaseous reagent. Option B, both reagents are gaseous, same as option C. So for this one, yes, pressure would affect rate, right? I can change the pressure of the gases. But in the last option, none of the reagents are gases. Right? So definitely pressure will not affect reaction D. Let's look at question 14. Copper 2 oxide catalyzes the decomposition of aqueous hydrogen peroxide to give oxygen and water. So this is very important. It tells you that copper 2 oxide is a catalyst and therefore it should speed up the reaction and remain chemically unchanged. All right. Okay. So if you look at the rest of the question, they are asking you, what did the test tube contain when the reaction was complete? All right. So what would you observe? Okay. So what you have to know is, in this case, copper 2 oxide is a black solid. All right. And since it's a catalyst, it should remain as a black solid after it catalyzes the decomposition of hydrogen peroxide. All right, so if you look at the options, only option A shows a black solid. Now, why is there a colorless liquid? It's because hydrogen peroxide, upon decomposition, forms water and oxygen. Hydrogen peroxide itself is a colorless liquid. And you should know that water is also a colorless liquid. So A is the correct answer. All right. The other options, okay, where you see that there is no black solid, right? Instead, you have a blue liquid, a light blue solid, a pink brown solid. Okay, all these actually indicate that copper 2 oxide has somehow changed into, let's say, copper 2 sulfate. So you get a blue liquid. Right, or it has turned into copper 2 hydroxide, which could be the light blue solid, or it might have changed into copper metal, which is the pink brown solid. Okay, so the last three options all show that copper 2 oxide did not remain chemically unchanged. It turned into something else, so it cannot be acting as a catalyst. So A is the correct answer. Okay, let's look at question 23. Question 23 shows you energy profile diagrams. And when you add in a substance X to the reaction mixture, it changes the reaction pathway. Right, so focus on without X and with X. Right, so you need to take note that with X, the activation energy is lowered. So in this case, you have to conclude that X is a catalyst in this reaction. Okay, so which change is likely to be observed when X is added to the reaction mixture? Right, so the last lesson I did remind you, all right, when a catalyst is added, only the EA is lowered, but the enthalpy change of the reaction, which is indicated by this part of the graph, remains the same. Correct? So the reaction will not become more or less exothermic because delta H remains the same. All right? But because X is a catalyst, so we are going to increase the speed of the reaction. Okay, let's look at questions 9 and 10. You are told that 0.1 gram of magnesium ribbon reaction took place at 18 degrees Celsius, and this is the volume and concentration of hydrochloric acid that was used. So they collected hydrogen. The volume was measured at 30-second intervals, and you get the graph. okay, that you see. All right. So what time was required for half the magnesium to react? Right, so this was something that I mentioned to you before. So what you should do in this case is, first you look at the graph and find out total volume of hydrogen formed, okay, which is from the graph 90 cm cube. All right, half of the reaction means 45 cm cube of hydrogen formed. Right, you cannot use the timing because, like I mentioned in class before, the rate of reaction is not constant. All right, the gradient becomes less and less steep. Okay, so instead of looking at half the time used, you should be looking at half the amount of products formed. So at 45 cm cube, which is somewhere here, okay, then you read off the graph. Okay, it's not very accurate, but on your own worksheet, please use a ruler, okay, to help you. But I think the answer should be 1 minute. Question 10, related to number 9. Which one of the following factors would not result in an increase in the initial rate of reaction? So if you were to look at the original conditions, I'm using 0.1 gram of magnesium ribbon. It was carried out at 18 degrees Celsius, and I'm using 20 cm cube of 1 mole per dm cube HCl. So these were the original conditions. So if you look at the options given to you, powdered magnesium versus magnesium ribbon, this would increase rate, right? Because powdered magnesium has a bigger surface area. 30 degrees, higher temperature, so definitely rate is increased. Okay, using a catalyst definitely will increase rate. Okay, option D, 40 cm cube of 1 mole per dm cube hydrochloric acid. Now, even though we are using a bigger volume of acid, but the concentration remains the same. Right? So in this case, there is no change in the rate of reaction. All right, and the correct answer is D. Now, for those of you who are wondering about option C, why is it that when I use a bigger mass of magnesium ribbon, the rate will increase? All right, so the explanation is because it is a piece of magnesium ribbon. So let's say this is 0.1 gram. Therefore, if it's a 0.2 gram magnesium ribbon, it would be about twice as long. Right? So if you look at the diagram, you can see with a 0.2 gram piece of magnesium ribbon, this will give us a bigger surface area. All right, so this one would definitely increase the rate as well. Next question, number 25. You are told that crystals of sodium carbonate were added to excess sulfuric acid, and this was carried out at room temperature. Okay, so from this alone, you can figure out that sodium carbonate is the limiting reagent, and this will impact the yield, which is the volume of carbon dioxide formed. Okay, so again, we are measuring the volume of CO2 produced over time. Okay, results are shown in graph Y. So this is the original graph. Okay, and after that, experiment was repeated. Graph Z was obtained. Right. So before looking at the options, I would like you to take a look at the graph itself, and from what you see to figure out or to make some conclusions. Okay, so number one, if you look at the yield, all right, I need you to see that Y produced double the CO2. Okay, And since sodium carbonate is our limiting reagent in this case, then you can conclude that for graph Y, we used twice the number of moles of the limiting reagent sodium carbonate as compared to Z. Alright, in order to obtain this graph, I would have used twice the number of moles of sodium carbonate for the first experiment, giving us graph Y as compared to graph Z. Okay, so this is what you must be able to conclude. The second part, which is important, would be the initial gradient. So you can see that for both experiments, the initial gradient was the same. Alright, so this also means that both went through the same rate of reaction. Okay, so the key here for this particular question is for you to focus on the fact that Y produced double the volume of carbon dioxide. So I must have used twice the amount of sodium carbonate, all right, in the first experiment as compared to the second experiment. So the question is asking what change was used to obtain the results shown in graph Z, right? The answer would definitely have to be C, right? Half the amount of sodium carbonate was used because, again, like I mentioned, it's the limiting reagent. All right, so to get that graph, I must have used only half the amount of sodium carbonate. Okay, for the other three options, why are they wrong? It's because if I use half the original concentration of the acid, I would have decreased the rate. But the graph shows that rate didn't decrease. Same thing for B. If I use lower temperature, I would have decreased the rate, but that's not what is shown in the graph. The last one, larger crystals. This one would also give us a smaller surface area, all right, which means that the rate is decreased. All right, so the correct answer is C. Okay, if you look at your notes, there is a little practice on sketching graphs. Okay, when I change different factors and how that will impact the initial rate of reaction as well as the amount of products formed. Okay, so do this in your own time. I will upload the answers for you on Google Classroom. Okay, so for question 1, I would like to give you a hint. All right, you see that we are using different acids. Okay, so in this case, I want you to consider the concentration of the hydrogen ions in the different acids. Second question, we are using different metals, so consider the reactivity of the metals. Okay, questions 3, 4, 5 are more straightforward, so I'll just leave you to do those on your own. Okay. Right, one more part that I want to go through with you is this last thing here. If you are given a graph of volume of gas versus time, how do you then convert this to a rate time graph? Okay, this one that's given in the notes is it looks pretty complicated, so I have a simpler one for you here. Okay, so I'll use this as an example. All right, so in this case, if you look at the first graph, right, you will see that I have two curves. Okay, and the y-axis is the volume of gas formed, x-axis is the time taken, right, time in seconds. Okay, so in order to convert a volume time graph to a rate time graph, you have to focus on two things. Okay, the first thing would be, ask yourself, what does a point on the x-axis on the rate time graph mean? So if you have a point on the x-axis, it means that rate equals to 0. All right, so the reaction has stopped. Okay, so how do you tell when the reaction has stopped from the volume time graph? So you can see I have indicated, all right, time taken for A to be complete, time taken for B to be complete. So what you do is you will then mark out the same timings on your rate time graph. So TA will be here, TB will be here. What does the point on the y-axis mean? All right, so on the y-axis, it means that time equals to 0. Okay, so they're actually referring to the initial rate of reaction. Right, so if you look back at the volume time graph, you will see that this graph, right, graph A has a steeper initial gradient, so the initial rate will also be higher. Right, so you can mark out a rate for reaction A. Now reaction B, initial gradient is less steep, right? So it has a lower initial rate of reaction. Right, so on your rate time graph, you mark out a lower rate of reaction, label it B. After you have done this, then you can connect the points on the axis together, A to A and B to B, right? And the graph would be a curve, right? Because rate is decreasing over time, right? And then B will look like this. Okay, so if you want to apply this to a question, you can look at MCQ number 29, right, where you have something similar. Okay, so two separate experiments, equal masses of a substance are decomposed. After collecting the gas, right, a graph was plotted to show the volume of gas, okay, versus time. Okay, then they're asking you, how would the speed of reaction versus time graph look like? All right, so it's the same idea. First, you look at the initial gradient. Experiment 1, steeper initial gradient, so faster initial rate. Right, so in your rate time graph, A, faster initial rate, correct? Or actually experiment 1, sorry. All right, and experiment 2, the dotted line, right, shows a slower initial rate, so indicate this on the rate axis. Right, now time taken. Experiment 1 took a shorter time, right? Whereas experiment number 2 took a longer time. So after you have marked out the timings and the rates, okay, then you will draw the curve to join the points together like this. So your rate time graph should look something like that. Then you choose the correct answer, which is